Now, um, we're still on Docker. Actually, this will be the last week we'll be discussing Docker. But before I get into the new stuff, which is Docker Compose, I want to go back to last week's lab because there was kind of an interesting question that more than one of you actually put to me on Slack. And I just thought I'd go back to it and uh, present it to all of you. So you might remember last week we were creating a Docker image of our what I'm calling the user profile app, and then we ran our MongoDB server and our custom image of our profile app, and hopefully it all worked for you successfully. But one or two of the, for whatever reason, try to run the profile app kind of locally rather than via a Docker image. So what I mean by that is, so we started up the, or ye started up the MongoDB server as a container. So, essentially ran this command here. And I've done the same. So I've checked now to see is my Mongo container running, and it looks like it is. Yeah. And then uh, some people try to do the following. So here's the profile app, the user profile app inside VS Code. And if I start to try to run that locally, so I need to go down to the app folder, cd app, and then go node server. And the reason people might have done that is if I go back to the website, you will remember, hopefully, that when we were working on, I think it was this lab, which lab was it? This lab here, we were playing around with the same user profile app, but in that case, okay, we started up, if I scroll on down, we started up the MongoDB server. And then eventually we cloned the repo that contained the user profile app, which you did here, yeah. And then we tried to run it locally, and it seemed to work fine back then. So if I try and do that now, and if we wait for a few minutes, because what it's trying to do now is connect to the Mongo server, the Mongo container, and eventually it's going to timeout and fail. Just give it another second or two. At least I think it's going to fail. Yep. So eventually it throws an exception. And if we scroll back up, um, you see we're getting a database connection error. Now, why was that, I wonder? And I answered people with a kind of a one-line answer. I didn't get into the detail of explaining it though. So the answer as to why this isn't working is because my Mongo, when I started my MongoDB container, I did not use port forwarding. Okay. Uh, what does he mean by that? If we go again back to the lab, that's being last week's lab now. here. And here's how I started the Mongo container. And if you look through it in terms of all of the options that I'm passing to it, I'm not passing the -p option. The -p option is where we declare port forwarding. So the MongoDB server running inside my container is listening on port 27017. That's just the default one. But I haven't forwarded that port onto the host. So I cannot connect to the Mongo server essentially from outside the Docker network that the Mongo container is running in. And I'm running it on this particular network here. Okay. So when I run node server from the command line, then it's trying to connect to the MongoDB server using localhost 27017. And that port on localhost has not been forwarded onto the containers port. And that's why it crashes. That's why uh, the node um, application crashes locally. Um, and I mean, it was very subtle, but if we go back to the lab that we did a number of weeks ago, if I go back to that lab again and look at how I started the server back then, where is it? I passed it. Here. Okay. You can see here, I am actually using port forwarding there. And so that's why it worked back then, but it doesn't work, didn't work last week. And in general, um, we would only use port forwarding, like the problem with port forwarding, if you use port forwarding for every container, then potentially you're opening up your application for hackers because the more ports that we make available, um, the more potential there is for hackers to get access to our application, in this case, to the database. This is now, of course, if we're running it up in the cloud environment. So that's the explanation as to why when I run the node server.js locally based on last week's setup, that it didn't work. Okay. Even though the image version of it would work, and if I just start the profile app in its kind of container form, because at the moment now I only have one container working. That's the MongoDB one. I don't have my profile app running. But if I try and run, let's see. Yeah, if I go back to last week's lab, start up my container, having built it, which is like this. And I'm purposefully going to make a mistake again now, just to see, because again, this is something that he would have encountered. So I'm going to try and start up my another container. I'll just open up a new shell just for convenience. And before I hit return, I'm going to predict that this is not going to work. Well, rather than me, let's just go for it. Boom, boom, boom. So it started up an image. Okay. I'm slightly surprised at that, but anyway, let's see if it to here. Go back to the other shell. Okay. Uh, I didn't mean to kill that now, actually. Can I just undo all of that again? I want to kill that container. Um, Sometimes the doesn't allow me to delete the container from the GUI, so I have to do it from the command line. So let's do that. And I need to stop the container first. So it's going to be Docker stop profile app is what I call the container. And then remove it. So my container is now gone. Yep. And I'm going to go back to when I tried to start the profile app from the command line. So if I just run this again, even though it's going to fail, am I the right one? Sorry. Now it is going to fail for the same reason, but if I go back and now try and start my containerized version of the profile app, just check that now again. Okay, go back to here, try and start the containerized version. And I get back this error, and the error this time relates to the port. You see, I'm trying to start my container and I'm using port forwarding, as you can see from here. Okay, and I'm trying to map port 3000 on the host machine to port 3000 in the container. But in my other over here, this is still running. The crashed version is still running. And when I started that, well, it eventually has exited now, actually. It's exited eventually, but I tried to start that and it was also using port 3000. And that was determined by my environment variables up here. Okay, I'd set it to use port 3000. So sometimes people get that error when they try and start a container that is trying to use port forwarding. The port they're using is already in use. Okay, so if I stop, which it has stopped itself actually, if I stop the local host version of my profile app and then go back and try and start the container version of it, the container version of it will run now. But of course I can't. I must yet again. You can see here, this is the containerized version of it. It's not running. It's in a kind of created state. Now, sometimes I can delete it from here, sometimes I can't. I'll try and delete it again. Don't think it's going to work though. Um, no, you see, it's not deleting. So I have to stop the container and then delete it. And I'll do that from here. now I'll start my container again. And this time it should be okay. Yep, looks like it's fine. Go back to here and go into 3000 and everything looks fine. Okay, that's one issue. The other thing I want to kind of remind you of really, because I have already kind of stated this and you may already be familiar with the point that I'm trying to make. But if I go back and I can stop that container again, stop it and remove it. And remove it. And I'm also going to stop the Mongo server. I think it will allow me to do that from here. That's kind of inconsistent, but that's okay. Okay, and I'm going to restart the Mongo server, but I'm going to give the container a different name. So let's see. Can I recall that command when I started it? Yeah, let's supposing I rename it to, I'll just give it any name at all, really. I'll call it my Mongo. And I won't use port forwarding. That's not required in this case. Okay, so that looks as if it's up and running. Yeah. And now if I start my user profile app in a containerized form, so I'll go back to here just for convenience, and I recall that command. Okay, so I'm running in background mode, and the container is going to be placed on this network, which is the same network as I started the Mongo server. I'm going to call the container profile app, doing port forwarding, and then I'm setting some environment variables. I'm setting Mongo password to admin, to secret, and I'm setting Mongo host to MongoDB, and that's the image that I want to run. Now, this isn't going to work. I'm just going to allow, I'm not sure if anybody's going to speak though, but I'm going to ask, why isn't it going to work? I'm telling you this is not going to work now, and I'm wondering why do I know it's not going to work? Does anybody have a suggestion and a microphone that you're allowed to speak? No. Uh, so let's give it a go. Well, it has started a container, but way over here, container looks like it's running. So far, so good. If we try and look at the logs for this container, uh, it's okay. It looks like it's okay. If I bring it up, oh, you can see now, look, the container has exited, so something has definitely gone wrong. And what has gone wrong in this case is my user profile app is referring to the database as MongoDB. That's the domain name that it's using for the database. This environment variable here, this one here, and you'd have to know that about the actual application, the user profile application. This environment variable, you set it to the domain name of the MongoDB server. Now, when you're running your MongoDB server in a containerized form in Docker, the domain name is equivalent to the container name of the MongoDB server. And I started the MongoDB server giving the container the name mymongo. So that becomes the domain name within the network that the Mongo server is running in. Okay, that's important as well, within that network. But I know both of my containers are running in the same network, so that's not the issue. The issue is uh, there is no server running within the Mongo network. There's no server called MongoDB. Certainly there's no MongoDB server called MongoDB. So if I change that, so I need to again stop my container, and again I have to do this from the command line, unfortunately. Will it let me do it? Let me try and do it from here. It doesn't like it. That sort of used to work, but anyway. And again, you can't delete it directly. You have to stop it first, then delete it. And now if I restart the container, or well, I have to create a completely new container. So back to here, but I need to change this to my Mongo. And I think it's going to be happy now. Takes a little while for it to connect to the server, but if I just go to the browser and do a refresh, it seems to be okay. Again, if I go back to the actual container itself, it's still running. So it would have timed out by now at this stage, but it hasn't. Okay, so there's 2 points there, the port forwarding and the relevance of port forwarding and how it can affect our setup. And the second thing is that the name you give to a container, that becomes the domain name for the application running inside that container, should other containers wish to connect to it. And the last point I'll make is, to connect to a MongoDB server, what the client has to do. Now, you don't usually need to go looking inside the code, but in the case of a MongoDB server, this is the URL that you use to connect to it. This is the protocol, MongoDB // the the admin username the admin's password, then the @ symbol, and then what I'm calling the Mongo host here, but that's really the Mongo server's domain name, and then the port. And in our case, the port was set to 27017. We set all of these environment variables when we start the container. We set them from the command line. That's what I was doing down here from the command line. Some of them we didn't set from the command line, so they had default values, and the default values was actually dictated by Docker file. Here's the Docker file. And, we have a default value for example, the Mongo user, and we have a default value for the Mongo port. But those default values can be overridden. They weren't in our case. We did override these ones, even though they were set to the empty string. Right, so that's just a little bit of on the kind of debugging side, and two of the common errors that arise or may have arisen last week and may arise in the future. Right, so let's talk about something new, which is back to our website. So the last aspect of Docker that I want to look at is something called Docker Compose. And Docker Compose is related to the whole area of multi-container applications, which is really what you were doing in last week's lab. But it was quite kind of long-winded the way we had to set up our multi-container environment. So this Docker Compose tool, which comes automatically when you install the Docker platform, um, it essentially it simplifies the creation of the runtime creation of a multi-container application. So on this slide here, I'm saying, uh, what would be the case from a developer's perspective if we didn't have Docker Compose, and what's the situation when now that we do have Docker Compose. So, I mean, you could say that up to now, we haven't had Docker Compose, but we have been creating multi-container applications last week. So the kind of steps are this, right? You actually have to build and pull down all of the different images that are required for your application. You have to do that kind of manually. And you have to run each of the containers individually from the command line. You have to start them up from the command line. And that's always an error prone. Uh, Anything manual is error prone. Also, I'm saying we have to kind of manually connect the containers together. We have to create the network that they're going to use, and then make sure that we specify that minus minus network option when we run them. Um, so again, that's kind of something that we are responsible for every single time we want to start up our multi-container application. We have to do this. Uh, the containers in a multi-container application, generally they have to be started in a particular order. So you might have seen there last week, we had to start up the Mongo server first. We couldn't start up our user profile app or the Mongo Express app. We could not start them up first and then start the Mongo server, because the applications, the web applications, would obviously throw an exception saying they can't connect to the server. So again, we're kind of responsible for that. However, Docker Compose on the right-hand side, it takes care of all of that. What we have to do is we have to define our multi-container application in a compose file, which is a file of the YAML format. So we do have to write that. I guess that's maybe an extra burden on us, but we write it once, and then we use a very simple command from the command line to tell the Docker Compose tool, start up my multi-container application and use this YAML file as the set of instructions as to how you should start up the various containers. And it takes care of handling starting up the individual containers in the right order. It manages the networking side of things, uh, and it also manages something called volumes, which we haven't really talked about in any details so far, although we have used it actually a number of weeks ago. So I need to explain what I mean by volumes. So Docker Compose is really targeting the uh, the runtime creation of your multi-container application. And so the steps now are we have to define, we still have to write our Docker file for that part of the multi-container application that we have control over, the source code that we have control over. So we write our Docker file for that as before. Then in the language of Docker Compose, we define the various services that make up our multi-container application. And essentially each container, we refer to it as a service. So in the case of our user profile app, we have a MongoDB service, we have a Mongo Express service, and our user profile app, because it is also be containerized, then it is a service within the entire application. So we define the services in our Docker Compose YAML file, and then we run this simple command, Docker Compose up. And up is kind of, you want to set the whole thing up. There is another option which is down, and down is when you want to essentially tear down the entire application. Okay, so it's a very simple command, and it takes care of creating all the environment for our multi-container application. Docker Compose is based on kind of three building blocks, okay? Services, which are our individual containers that make up our application. Networking, obviously we know the importance of the role of networking in a multi-container application. And the third thing is volumes, and volumes is related to if you want to have any persistence of data within your multi-container application. For example, our MongoDB server, if we want to persist the database, the state of the database, after we shut down the server, then we need to leverage something called volumes. Because if we don't have volumes, then that means the next time we start up our MongoDB server in this multi-container application, the database is just going to be reset back to zero. Clearly, that's not a clever idea in a production environment. This is a very simple example of a Docker Compose YAML file. So at the very start of it, we have a services section, and then each of these is essentially a container. So that's one container. And in this case, this is a second container, and it looks like it's our user profile app. Well, is it? No, not necessarily. It's more generic. Okay. And the the settings here for each of our services, the, you know, they're obviously related back to how we started our containers from the command line. So the setting allows us to control the name of the container that's going to be created for this service. The service name is completely arbitrary, okay? Can be anything you want it to be. Um, Here we're specifying the image that we want to have associated with the container. In fact, it is our profile app, yeah. This option here, you would only use this option if you have the Docker file for this particular image locally, which we do in the case of the profile app. And so the dot just simply means it's telling it where to find the Docker file. And obviously dot means it's in the current directory from wherever this file is, wherever this physical file is, in the same directory, there will be a Docker file. And so if there is no, in this simple example, if there is no image, just 1 second now. If there's no image called that in my set of images that I have locally, then the effect of this setting here will cause Docker Compose to actually build the image. In other words, it'll go find the Docker file and it will execute the instructions in the Docker file. And it will create an image called this. So the first time I run this Docker Compose file, that's supposing the image isn't there at all. So it's going to build it. The second time I run this Docker Compose file, it'll find the image. So it won't need to build it. Uh, ports is, again, that's related to port forwarding. So we're specifying port forwarding here. We have only ever had examples of uh, using port forwarding for one port in the container, but it's possible that a container may be listening on more than one port. So you can actually have multiple entries in this ports section here. Environment is the setting of environment variables for our container. So that was the -E option when you're doing it for the command line. The depends on controls the order in which containers are started up by Docker Compose. So we're telling Docker Compose that this container stroke service depends on another service called MongoDB, which is this one direct right down here. In other words, it's going to start this container first and then start this container. And it depends on, could have a number of entries in it. Again, there's only happens to be only one here. So if there were 5 or 6 other containers within this overall multi-container application, and this particular one, not only did it depend on MongoDB, but it also depended on another container, then you would simply put a little dash here and then name the container here. Sorry, I'm saying name the container, name the service. There is a difference between a service name and a container name. I mean, as is evident here, I've decided to call the container profile app, but I'm just calling the service app. You can make them the same, they can be different, it's completely arbitrary. But in the depends on property here, you specify the services that this one here depends on. Our second service is MongoDB, container name. Clearly, like we are not going to be able to build the MongoDB image locally. Okay, so we don't have a build option here. We do have a build option here, but it doesn't make sense to have it here. We're just specifying the actual image that we want this container to be based on, ports as before, environments as before. Yeah, that's a simple example. And as you may know about YAML, you've got to be very careful about indentation and alignment when you're writing YAML code. As I think about it now, we haven't written any YAML so far, uh, but I'm just giving you kind of a warning that you do have to be very precise about the indentation and alignment. Uh, if we want to actually pass environment variables to our Docker Compose file, now if I go back, environment variables are kind of all over the place, but the environment variables that we're mentioning here, okay, these are environment variables that you are passing in or making available within your container for the particular application that's running inside the container. But what if you actually want to pass environment variables into this file itself, into Docker Compose? Okay. So again, the ways that we do it are the ways we work with environment variables right across the board, really. We can create a .env file and declare our environment variables there, or we can pass them from the command line when we try and run Docker Compose. And what do I mean by run Docker Compose? If I go back a few slides, if we simply run this command from the command line, Docker Compose up. If I ran that command from the command line, and this is my Docker Compose file, then clearly what Docker Compose is going to do is it's going to create two containers and configure them accordingly. Now, back to environment variables. If I want to pass environment variables, okay, I can either, we'll only use this option, this approach, the .env file. And we know what a .env file looks like. The question then is, how do I reference my, so I'm giving you a simple example of a .env file here. How do I reference those from within my Docker Compose? Well, the syntax looks like this down here, right? And excuse me, environment variables can be used for any part of my Docker Compose. You know, I might want to pass as an environment variable this host port number, or the container port number, or I might want to pass the dependency, which would be odd, but I can anyway. Or which is probably more likely, excuse me, you want to pass the settings for the containers environment variables. You want to pass those into Docker Compose as environment variables themselves. And that's essentially what I'm doing kind of down here. And I'm also doing up here. Because here I'm saying this is the environment variable name, this is its value. Okay. And in fact, there's more than one way of writing this. So we've got the dollar symbol, the curly brace, the name of the environment variable. So this has to match one of my environment variables here. And close my curly brace. In fact, you can leave out the curly braces and just go dollar, the environment variable name. That's what I've noticed when I've played around with this. So that's how we pass our reference environment variables within our Docker Compose. Obviously, networking is very important in Docker Compose because you want all of your containers to be on the same network. So what I'm showing you here is an excerpt, and I'm showing you how to bring in the networking side into Docker Compose. So as well as services, okay, we've got a networking section here, and you can declare any number of networks that you want to. So here looks like I'm just declaring one network. This is the name that I want to use for the network within Docker Compose. This is the name that I want to have appearing for the network when I list my networks from the command line. When I do Docker network ls, this is the name that I'll see. But you can give the network, any name you want to within the Docker Compose file. So I've decided to give the network the name profile network. And then down here in my services, any service that I want to put on to or connect to this network, then I have to include the network section within the service configuration. And here I'm just referring to the network. And again, there can be more than one. I'm referring to the network by means of the network label, I suppose. So let's use that term that I've used up here, not the name that you give it here. So it looks like both of my containers here, I'm actually adding them to the same network. And I should just explain as well, there are a number of settings that you can have, but the setting here of external, and I'm setting it to false, What that means is I want Docker Compose to actually create this network when I do my Docker Compose up command. Yeah. If I'd set it to true, then I'm telling Docker Compose this network already exists. It has been defined externally from Docker Compose. In other words, I created it from the command line myself. Okay. So when I do Docker Compose up for this Docker Compose file, it is actually not only is it going to create all my containers, it's going to create the network as well, and it's going to put my containers on this network. And when I do Docker Compose down, it will remove all of the containers, delete them. It'll also delete the network. Now, if I go back a couple of slides to here, I said there are three kind of building blocks related to Docker Compose, and we've looked at two of them, services and networks. The last thing I want to look at is volumes. Check my watch. Now, I didn't really expect to get through all of these slides today, so that's okay. What I'm going to do is I'll keep going for about another 5 or 10 minutes or so, and I'll finish off these slides in a short lecture tomorrow morning. And then the lab for this week will all be about Docker Compose. So, and I'll publish a message on Slack about tomorrow's lecture. So, what volumes do, I'm saying here, is volumes map file systems on the host machine to the file systems within a container, to the file system within a container. Or put another way, it maps uh, directories or individual files on the host computer to directories or individual files within the container, so that when the container runs, when it's trying to access particular files or folders, the actual physical file or folder that they will be accessing is kind of outside the container, and it's part of the host computer's file system. And we've actually seen that way, way back, if you remember, when we used the -v option. This is how we specify that we want to use a volume mapping for a particular container. And so the way you interpret this is go to the website folder on the host machine, and the website folder is a subfolder of the current folder, the dot slash here, you can just about see. So take the contents, take that folder and map it to this path inside the container. And you might remember this path actually relates to the Nginx image, but that last part isn't really important. Okay, this is how we specify. This is one way of specifying a volume mapping for a container. Why it's really, it has kind of two purposes really, but the probably the most common use for volumes is data persistence. And I'm saying it allows data to persist for longer than the life cycle of a container. So if I start up a container and and the container, it's, let's say it's a database container, doesn't have to be, could be any container at all, running any image, and I have a volume mapping for it. If during the running of that during the running of that container, it actually makes changes to, this case, this particular path here, makes changes to files inside in the HTML folder. When I shut down that container, all of those changes have now been lost. And you may not want that. You may want them to persist such that the next time you start up the exact same container, it will be reading the most up-to-date data or contents of this particular folder in this case. Hence, we want to persist any changes that a container makes to its file system or part of its file system. Okay, there are two types of volumes. One is called bind mounts, and the other is called named volumes. And the shorthand is like this is a bind mount type volume here. But let's go into those two types in a bit more detail. So I'm saying bind mounts is where a file or directory on the host machine is mounted into a container. Okay, and that's what I've kind of been talking about up to now. Uh, Additionally, if the actual file or directory doesn't exist on the host, then the bind mount will actually create it for us. Okay. The bind mounts, okay, we're saying they're very performant, but yeah, they do rely on the structure of the file system on the host computer to match a particular pattern. And kind of what I mean by that is if I just go back to here, rather than specifying a relative path name here, supposing I specified an absolute path name for the host uh, directory. It's a directory in this case. Now, that absolute path name may not be the exact same, certainly wouldn't be the exact same on a Windows machine versus a Mac. So if we use an absolute path name here, it's not really going to work. So you have to be careful about that. Um, sorry, that's the point I'm making. Sorry, where did I make that point? Two bind mounts. Oh yeah, I just made that point here. From a visual point of view, this is what we're trying to visualize. Here we've got our container. Here we've got the file system of the host machine. That's what that's representing. And a bind mount is linking a path within the container to some part of the file system on the host. Okay, we've made that point a couple of times. This is just a visual representation of it. The other point I'm making here is that we cannot use the Docker CLI commands to directly manage bind mounts. Okay, that'll become clearer when we actually talk about the other type of volumes, which is named volumes, because you can use the Docker CLI to manage your named volumes. You can't really do anything with bind mounts from the CLI perspective. So more stuff on bind mounts. Create a bind mount. There are two ways we can create bind mounts. This is the way we've seen already. Okay, so in general, it's the -v option. The source path name. By the source, we mean the host path name of the file or folder that we want to have mapped into the container, colon, and the target path name is the container's path name where we want it mapped to, colon, and then there are some options that you can specify. The most common option is the read-only option. That's what RO stands for. So if you do specify the RO option, that means the container during runtime, it cannot actually write to this path, which means it cannot actually make any changes to the files on the host machine. If it tries to do that, then I guess the container is going to throw an exception. And the rest is as before, container name and whatever the image is. Creates, I've mentioned that already, creates the file, the source file or folder if it doesn't exist. The target path is the container path, that's all right. The options, that's okay as well. Here's the second way or another way of creating a bind mount. So it's this --mount option on the docker run command. And its setting is, so you set the type to bind. There's no option there. So that's telling the Docker daemon that we're creating a bind mount. Again, it's the comma, the string source, and you set that to the path name, the source path name, comma, target equals the target path name, comma, and then any options. And for the mount minus minus mount form, we're a bit more explicit. The options, one of the options is read only. So it's a bit more, there's certainly more typing involved here, but it's more explicit as to what you're actually doing here. So there are two ways of creating a bind mount um, between the host machine and a container. Now, the only difference when you use this minus minus mount approach or form, it's actually going to throw an error at runtime if the source path doesn't exist. So it's slightly different behavior to the minus V option. Right, I am going to stop here and I'm going to finish these slides, which won't take me a whole lot of time, I think, tomorrow morning. And then I'll let you work on this week's lab, which is all about using Docker Compose. So I'll talk to you tomorrow morning. Thanks. So I just want to finish off our discussion on Docker Compose, which I started yesterday. So again, I am working my way through these slides here. And then when I finish, you can start working on this lab here. So what Compose is all about is multi-container applications. Now, we've already done some work in the labs on multi-container applications. So in a sense, Compose doesn't give us anything new. It just makes starting up these multi-container applications a little bit easier. It takes away the manual effort associated with it, which is what we've been doing up to now. And so the kind of process is you still have to write your Docker file for that part of the multi-container setup that you develop. And then you write a compose file, which is a YAML file. The name of the file is not actually prescribed, unlike Docker file, which is prescribed. You can give the compose file any name you want to. It just has to be in YAML format. And then once you've written that, and in this compose file, you are describing the different parts that make up your application. In other words, the different containers that make it up. Although we don't use the term container, we talk about services. Also, you talk about the networking side of it. And the third part of a multi-container application is what are called volumes, which we need to discuss a little bit about today. Now, I could have talked about volumes at any stage. Volumes is not specific to Docker Compose. It's a Docker thing rather than a Docker Compose thing. But either way, once you've got your Compose YAML file written, then you simply issue this command to create and start up the different parts of your multi-container application. So yeah, so these are building blocks, services on the left, which are really containers, which we've talked a lot about. Networks there on the right, which we've also talked about. This is networks, virtual networks in the Docker Compose sense, and volumes there in the middle, which I want to talk about today. But as I've already said, they're not specific. We can use volumes outside of Docker Compose, and I'll do a little bit of that with you today. This is what a Docker Compose file looks like. So I kind of talked my way through this yesterday. So I'm just going to push on to volumes. which I did start talking about yesterday. And what volumes in the Docker sense allow us to do is it allows a container to access files on and or folders on your host computer's file system. So in a sense, volumes breaks the isolation principle that I've mentioned a couple of times that Docker gives us. Because if you think about isolation, isolation is about a container being completely self-contained and it doesn't need to know anything about, it can't be accessed outside unless, of course, you expose one of its ports using port forwarding, which we talked a bit about yesterday. Well, it turns out that volumes now uh, is another part of Docker, which allows a container to access stuff outside of its environment, in particular to access files and folders. Um, which actually can be a very useful thing. And in particular, what it's useful for is if you've got a database container within your application and you'd like any changes that the application at runtime makes to that database, you'd like that to be persisted in such a way that if you shut down the application and start it up all over again, it will have the most up-to-date version of the database. But in general, any type of data that a container, it may want to persist the data uh, outside of the life cycle of the container. And that's what volumes allow us to do. Uh, there are two types of volumes. There are bind mounts and named volumes. Bind mounts are where you are giving the container access to a particular file or folder on your file system. And you can see that file or folder using, the Finder tool or the Finder application on a Mac. On Windows, it would be Explorer, I guess. So you can actually see the files and folders in the same way that the Docker container can see them. So as what bind mounts are, and let's see, okay, so the visual or the image there is kind of trying to get that across. Here's our container, and a bind mount is access to a particular part of the host computer's file system. This is how we create the bind mount using the -v option. So I'm just going to switch over to VS Code just to give you an actual demonstration. And we've actually seen bind mounts already. In fact, could have been in the very first lab that you did on Docker, but I didn't talk a whole lot about. I don't think I may not have even mentioned the term bind mounts. So let's. So what you're looking at here now is just a simple folder that contains an index.html file. Yeah, it contains a Docker file as well, although the Docker file isn't relevant at all here. It just happens to be hanging around, but it has no other purpose. There's another file as well that we're not interested in. Well, actually going to use the contents of it just for convenience. So what I want to do is I want to start up an Nginx server, and I want that Nginx server to serve this file as its homepage. Okay. And if you remember, that's something that you've done already. As I said, you've done it in the very first lab, but just to remind ourselves. So I think this is the command here. So rather than me typing it out, I'm just going to grab this. So just to scan across it, we're doing Docker run in background mode. We're doing just some port forwarding because we know all about that. And here's the bind mount part. Okay. And the syntax is you specify, first of all, what's called the source path or the source folder. That's a reference to the folder or file on the host system. So in my case, it's quite simple. It's just dot slash. So I'm referring to this folder here on the left. And I am binding it to or mounting it on uh, this part of the containers file system. We refer to this as the target path. And I'm sure this is coming back to you now because, as I said, we've done this before. And the rest then is nothing unusual. So let's just run this command if I just grab it. Okay, that's my container up and running. Let's just check it. And let's see. Did it start up? I think it did. There it is there. And if I just click on this, then here's the page that it's showing me. And that is exactly the same as the index.html. Yeah, so that kind of demonstrates what we're trying to get at here. Now, if I go into the container itself, if I open up a shell session or a terminal session, which is let's do it manually, I guess. Docker exec. And Nginx server, is that what I call it? Yeah. Part of a shell. And if I cd down to this path here within the container, and if I do an ls, then we're seeing the set of files that are on my file system. Now, what you're seeing here is not a copy of the files. The we're actually uh, we're actually seeing the actual files on the host computer's file system. And again, to kind of further prove that, if I try and make a change to the index.html inside of the container, and then when I look at the file out here in the file system, I'll see the change has been applied. Now, this is the way I'm actually going to do it. I'm just going to write some HTML to the file. And just to view it in the browser, I've written hello world to the bottom of the file. Yeah, that's coming up there. But if I also look at it on the host file system, then I can see the hello world being written to the actual file on the host file system. Yeah, so that's bind mounts. Let's come out of this. Now, what you can also say when you're setting up a bind mount, you can declare it as being read-only, which means the container is not allowed to write to the actual file system. And so if I start up a second container, and I'm just going to call this one Nginx Server 2. And the way I declare it as being read only is by adding another colon and the read only. All right, the port, I have to use a different port for this one. Cannot have two containers mapped to the same port, the same host port. So I go 8002. Just need to check now. Sometimes it actually creates the container. Yeah, it has created it even though it's exited. So I need to delete that first. That's my container up and running, and it is looking at the same file. Manual refresh. Yeah. Now, the problem though is if I now go into this container and try to do the echo command again, then it's going to fail. So I'll exec into it. CD down to the folder. Try this echo command. Okay, and you can see it's not allowing it because it's in read only. The nature of the binding has this read only restriction on it. Okay, so that's bind mounts. Now there is a second way of creating a bind mount. There are two kind of syntaxes. The second syntax is this syntax here, and I'll just briefly create a container using that. So if we exit out of this, and I'm just going to do a cleanup really. Now this minus minus mount option does the exact same thing. It's a bit certainly it's more long-winded. There's more typing involved, but the argument in favor of it is that it's more explicit. So, it's the minus minus mount option. You set type, then type is set to essentially it's set to this big long string here. That's comma, it's a comma separated string. And so we're specifying what type of uh, mount are we doing, and we're setting that to bind, sorry. Source is the path name on the host file system. Target is set to the path name in the container. And then at the very end, we have the options that are available to us. There are a number of them, but the only one we're interested in is read only. Or if you leave out read only, then it implies that the container can actually write to the file system. And so let's just grab this. So we'll leave it as read only. Like something. We'll type on it. Checking the syntax. What doesn't it like? Oh, okay. I'm not sure now what it doesn't like. Let me check it. It looks okay to me, so I'm not sure why it's complaining about it, unless somebody can see a typo. Docker run minus D minus P, that's the port mapping, minus, oh, sorry. Sometimes it's very obvious. Okay, and as before, so we called it, we're setting it to read only. Well, I mean, we could go into the container and try and update the index.html, but it's going to fail again in this case because we have set this property here or this option on the bind mount. But it's definitely working as before. If we go in and try and open up the page, then we're getting access to it. Okay, so that's back to my slides. That's bind mounts. Two ways of doing it. The other type of volume are called named volumes. Bind mounts have been part of Docker from the outset. Named volumes are a newer type of volume, although they've been around for a number of years. The difference, though, is that a named volume, it kind of visually, this is how it kind of looks. The actual, sorry, no. The actual data or files and folders are actually within the Docker space on your host computer. Okay, they're not visible from the file system. They're managed internally by the Docker the Docker installation on the host machine. So that's a downside of named volumes. You can't actually look at them. I couldn't open up in Visual Studio Code I couldn't look inside a named volume and poke around inside there. Okay, that's the downside. The upside, though, is that they're far more performant than bind mounts. The read-write time is much, much quicker. And arguably, named volumes now are more commonly used than bind mounts. So how do we create them? These volumes, we actually create them from the CLI. Docker volume create, and you just give a name to the volume, and you can call it anything you want to. So if we just go back to here, from the GUI side, we can actually look at the volumes from here. Now, I don't have any at the moment, but I think you will notice if you look at the volumes, there'll be quite a number of them there. So in fact, a number of the applications that we've been playing with up to now, they create named volumes behind the scenes. Excuse me. Unbeknownst to us. And what I've actually done is I've deleted all of those because we don't need to hold on to them. So if I just do a simple Docker create or Docker volume create from here, or with anything, I call it my vol. Okay, and there we can see it there. If you don't actually specify a name, then it will randomly generate a name. Okay, so that's the actual name that it is. It's kind of a hash value that is given to the volume, and there we can see it there. Now, we won't really need that today, so I'll just get rid of it. Now, as I said, we can't really look inside what is the contents of this volume. We can't really do that. But going back to my slides, so that's one way anyway of creating volumes. As it turns out, Docker Compose will create them for you as well. Docker Volume LS will just list all the volumes on your current system. Docker Volume Inspect does what you expect it to do. It allows you to look inside it. We don't really need to. Docker volumes remove RM to remove one, and Docker volume prune. That can be quite a useful command. What prune does is it deletes all volumes that currently are not being referenced by a container. If you have containers running and they are using, be it volumes that you have created or volumes that it has created, behind the scenes, it won't allow you to delete those named volumes for obvious reasons. But sometimes there are quite a number of named volumes that are created behind the scenes with kind of hash values, and it's quite useful just to get rid of all of those in one go using the prune command. So when you want to start a container, note now, I haven't talked about Docker Compose at all so far, and that kind of reinforces the point that I made at the beginning that these volumes are just part of Docker. They're not part of Docker Compose specifically. But if you want to create a container and link it to a named volume, again, you can use the you can use the -v option. The only difference here now is that this here now is an actual volume name as opposed to a path name. Okay. So if I compare and contrast that with, do I have it? Here it's a path name that you're going to be specifying. As in, well, okay. Anyway, you've seen lots of examples of that, so I don't need to go back to that. But now it's a volume name, and the target path or the container's path is going to be a path name as before. You can also use the ---- mount option for creating containers with linked to named volumes. So I'll just do a quick illustration of using this approach. So I've already created a volume called myvol, and let's see, what am I going to do? I think what I was planning to do is if I start up a busybox container, yeah, that's what I have here. So I want to run in background mode and also have an interactive um, session with the container. I want to name the container box one. I am linking the myvol named volumes to this path within the container, and the actual image is the busybox one. So if I just grab that, yeah, Control V. So there's my, and if I go into this container, now um, I've linked the my volume to let's see, to, where is it? Oh yeah, to the test folder, which is a subfolder of the root folder. Okay. Now that did not exist, but the Docker would actually have created the test folder for me if it doesn't already exist. So I'm now inside a container, and if I do just an ls, you can see the test folder there on the right. So if I go down into test, and if I do an ls of that, then, surprise, surprise, it's actually empty, because I've just created an empty named volume. But if I put a file into that named volume, so I'm just going to do this here, just using the echo command as a convenience, and I'm writing it to a file called data.txt. If I do an ls, there's my data.txt now. So let's come out of this container. And if I start up another container, it doesn't have to be a busybox container. It can be any container, but just for convenience, I'm going to create another container based on the busybox image. So I'll just call this box 2. And for no particular reason, I will, in this case, make it read only. Now, what I expect is when I go into the box 2 container, I would expect to find the data.txt file inside in the test folder. And again, it doesn't have to be test. I could give it a different folder, call it test2. Yeah. So now I go into box 2. ls. Uh, there's my test2 folder there on the right. Let's go down to it. Do ls. And, I have the file. So that kind of proves that uh, Docker is managing the contents of that named volume for me. And now if I try to, Obviously, if I try to do this, I call it data two, this is going to fail because I've started up this container and I've linked the my vol named volume, but I'm using read only setting on it. So if I try and do this, I think it should fail anyway. Yeah, so that's what's not allowing me to do it. Okay, so that's named volumes. The plus side is that they're more performant. You get a quicker uh, um, response from the named volume when you try and read it or write to it if you have permissions to write to it. The downside is you can't actually investigate the internals of the named volume from your normal kind of file system perspective. Now, going back to Docker Compose, how do we represent these volumes in Docker Compose? Well, it's like this. Again, you kind of work it out. So here we have in the services section, we've got a service called backend. It's using a particular image. And it looks like here we're using the bind mount form of the volume setup. So because it begins with dot slash or any kind of path name, that's telling us it's a bind mount. So we're linking the app folder in uh, the app folder in the current folder on our file system. We're linking that to the slash app path inside in this Ubuntu image. Uh, if I wanted to use the minus minus mount variation on this, this is how we'd write it. See, the assumption here now is that this volumes is part of a service setup. Okay, so we're replacing that with with this. Okay, so it is more explicit, as they say. The mount version of it is better than the this kind of shorthand version here. That's how we set up a bind mount in Docker Compose. A named volume is set up like this. Again, so it's the assumption is now is that this is an actual volume name. And what's we showing down here? Oh, sorry, yeah. So this is a volume that you're linking to this particular image, sorry, this particular service. It's a named volume, but separately in the Docker Compose file, you have a volumes section, which is kind of at the same level as the services section. And down there is where you can be more specific about some characteristics of the volume. Okay, so it's not enough just to name it here. You've also got to reference it down here. And there are lots of options available to you with these named volumes. If I go back a couple of slides. So for example, let's see here, right? This point here. The named volumes, they don't actually have to be local. They don't have to be on the host machine. The volume that I just created there a while back, clearly that's physically stored on the host machine. We can't see it in the file system, but it's stored within my Docker desktop installation. But you can also create name volumes remotely. So I might have an EC2 instance and have a named volume created on that in the cloud, or it doesn't have to be an EC2. I can create a named volume in the cloud, and I can link that named volume to a container that I'm running locally here. In other words, the named volume can be remote from where the container is running. Yeah. So that's one nice aspect of named volumes. And so if I go back to this slide here, you might actually specify that down here as characteristics of this volume. Also, what you can specify down here is you can say you can ask Docker Compose to create this volume as part of creating this entire uh, multi-container application. The volume can either pre-exist or you can get it to create it at runtime, which is what I am. Well, down here I'm saying external is true. External is true means that the volume already exists. So I would have created it from the command line. Set that to false or leave it out. I'm not sure what the default value is, whether it's true or false. Okay, that's volumes, and of course, like everything, there are other aspects of it that we haven't covered. So, in terms of this week's lab, essentially, what you will be doing is taking the user profile app, which I think I've loaded here. Here's the user profile app. You'll be creating a Docker Compose YAML file, which in my case is this one. I didn't call it Docker Compose, but I think you do in the lab. And if I just open that up, then here we go. I have a network section, and it looks like am I specifying? Oh yeah, I've set external to false. So when I run this Docker Compose, it's actually going to create a network for me. The name of the network is going to be this. However, within this Docker Compose file, whenever I want to refer to the network, this particular network, I use this name here. Here is my services section. Here's the actual user profile app itself. You can ignore that line there. Probably should have left that out. And I'm doing oh yeah, it's the build. I'm doing some port mapping, some environment variables. I'm linking this particular container stroke service to the network that I created at the top of the file. I'm saying that this service is dependent on the Mongo service, which is declared just down here. Here's the Mongo service. And I just collapse this for a second. It has a volumes section, and it looks like it's a named volume rather than a bind mount called source data. And if I scroll down to the bottom, here's the volume section, here's the source data. The name I want to give to the volume is my data. So that's what would appear when I look at the volumes using the GUI, and setting driver to local. Well, that just means it's actually stored locally rather than in the cloud. And I think what happens here is because I haven't told it that it's an external volume, it will create it uh, when it doesn't already exist. Yeah. In other words, when I run this for the first time, it will actually create this volume for me, and it'll name the volume that. Although if I want to refer to the volume internally within this Docker Compose file, this is the name that I use. And so we can confirm that when we look at the Mongo instance, that's the name that we're using here. I've also, just for the sake of it, included the Mongo Express application within this overall setup. Okay, so I guess I could just do Docker Compose up on that. Let's just do that, and then I'll let you work through the lab. So it's Docker compose. Now, when the file name is something other than docker compose.yaml, then you have to tell it the name of the file using the -f option. So I called it that. Also, I want to run it in background mode, -d. Sorry, that comes at the end. Up means I want it to create this multi-container application for me, and I want it to go in background mode. And you can see here, it has created the network for me. It has created the volume. Let's look at that. Uh, there it is there. What else? And it has created the 3 containers as well. Let's check that. Well, sorry, now the way when we look at it here, we don't see the 3 containers. What we see is what's called a stack entry. Where is it? Here's the stack here. But if I click on that, this is where we now see the different containers that make up this stack. I think if you look back through the slides, I mentioned this term stack. It's just the Docker Compose term. And so we've got our 3 containers. The profile app is in running mode. The Mongo Express is in, there's a problem with that. I have to go back and look at that. And the MongoDB server is there as well. I'm not sure now why it hasn't created this one, but I'll debug it later on. And if I want to shut everything down, then I just go Docker Compose down, and that just gets rid of everything except the volume. Clearly, it does not delete the volume. Otherwise, that would defeat the whole purpose. So everything is gone. Go back to here into my containers, and it looks like it's gone. Yeah, go back in again, start it up again. Okay, so it's creating the network every time. It's not creating the volume every time. It already exists, so it's creating my 3 containers. Okay, so going back to the website, you can now just work your way through this lab here, and I'll be available on Slack until around 12-ish if you've got any issues. Again, I'll allow you to ask questions if anybody has a question for me in what I've covered this morning. No. All right. So work your way through the lab and get in touch with me if you've got any issues. Thanks.